This lesson is on writing dissociation or ionization equations. We will start by looking at number 1. Number 1 asks for the dissociation equation of HCl or hydrochloric acid. Because HCl is made of two elements, hydrogen as well as chlorine, when placed in water, hydrochloric acid will separate into its individual ions. Hydrogen becomes a hydrogen ion, and chlorine becomes a chloride ion. If you're unsure why HCl will break down into hydrogen and chlorine, take a look at your data booklet. Hydrogen atoms produce hydrogen ions in water, and if we take a look at the next page of the data booklet, chlorine atoms dissociate in water to produce chloride ions. So in the question of whether or not HCl is an acid, a base, or a neutral compound, because it produces hydrogen and ions in water, it is considered an acid. Now let's take a look at the second example, NaOH. NaOH is made of a sodium ion as well as a hydroxide ion. On page 6 of the data booklet, in the top middle, is a list of all the polyatomic ions that we will use. Hydroxide ions are written as OH negative. So when we put sodium hydroxide in water, it will dissociate into its sodium ion as well as a hydroxide ion. Because hydroxide ions are produced, NaOH or sodium hydroxide is considered a base. In the next example with NH4Cl, this one can be tricky. NH4Cl is made of two different ions. We have the ammonium ion as well as the chlorine ion. Once again, if you're not sure, you can check on the polyatomic ion section of your data booklet. In water, NH4Cl will dissociate into ammonium, which has a charge of 1 positive, as well as chloride, which is a charge of 1 negative. Because neither a hydronium or hydroxide ion is produced, this is considered a neutral compound. We will now take a look at number 4. Number 4 is slightly tricky because we have to balance the charges when a compound dissociates. So when barium hydroxide is placed into water, it will separate into a barium ion as well as some hydroxide ions. Notice the number 2. In water, barium produces an ion that has a charge of 2 positive. This can be found in your data booklet. Barium is atomic number 56 in our periodic tables, and the charge is 2+. The other ion that is produced in the dissociation of barium hydroxide is hydroxide ions. Now this equation may look complete, but it is not balanced. On our reactant side, we have 2 atoms, or 2 hydroxide atoms, but in our products we only have 1. Therefore, we must add the coefficient 2. Now the equation is complete. And because hydroxide ions are produced, barium hydroxide is also considered a base. We will now try question number 7. Question number 7 starts with a compound of H2SO4. H2SO4 is considered an acid even before we write the dissociation equation. H2SO4 is made of 2 hydrogen atoms, a sulfur, and 4 oxygen atoms. Every time we write a dissociation, the compound only loses 1 hydrogen at a time. We will assume it is a weak acid. So in this question, if 1 hydrogen separates, what we have left is not just an SO4 or sulfate ion, but we have is HSO4. HSO4 has a 1 negative charge. Once again, if you're not sure, you can check the data booklet under the polyatomic ion section. Hydrogen sulfate. This dissociation equation is now balanced because we have 2 hydrogens on the reactant side, as well as 2 hydrogens on the product side, and an SO4 ion there, and an SO4 ion on the product side. You can now try the rest of the questions on this page. Don't forget to check the end of the video for the answers, and check with your teacher if you have any questions.